Leetcode problem 1278 Palindrome Partitioning 3. So for this problem, we are given a string S containing lowercase letters and an integer k. So we need to first set some characters of S to other lowercase English letters, and the second, we're gonna divide S into k non-empty destroyed substring such that each substring is a palindrome. So for example, in the first example, we can split it with A, B, and C. So for this substring C, it is a palindrome, it is okay. But for this A, B, it is not a palindrome, but we need to change one character. So we can change A to B or B to A. So it's gonna be, it's gonna be one change. So we're gonna return a 1. So basically, we are given this string, and we need to split it into k parts. And for the second example, we're gonna split it to A, B, B, and C. All of them are palindrome, so there's no character replacement. So we're gonna return a 0. So we're gonna solve this problem by using DP. But for me, I prefer use DFS because this is easier. So we're gonna prepare a DFS function, and the DFS gonna be the I and J. So I means from index 0 to n-1. So from the index 0 to I, it means from index 0 to I need to split the string into J part. J part here is the K part, but here this DFS I and J means from index 0 to I need to split the string, this is S, into J part. So if I split the string into J part, I just want to count how many character replacement or how many character changes. So this is a string from 0 to I, and for example, if the J is 3, so this means I need to split it into 3 parts. So for each part, I just need to calculate what gonna be the minimum character replacement if I were to make each part become a palindrome. If it is not a palindrome, I would to have the character replacement. So this is the idea. So, but this is going to be a brute force. We want to solve it like a DP, so we need to have the memorization. So for this I and J, it is okay. But we also need to prepare a counter. So this means we're going to enumerate all the possible cases from 0 to I. So for example, this is X. We want to check if 0 to X minus 1. So this is going to be the first part. So this is going to be the DFS from 0 to X minus 1. And what left behind is we're going to use a counter. So we're going to use a count because we can calculate the character from X to I easily. So from X to I, we just need to check how many characters we need to change. So for example, if we have a counter like ABB, so we have a ABB, and we can use this counter to check how many characters we need to change. This means from A to B, how many characters. We can change this A to B or B to A. It means we need 1 character replacement. So first of all, we're gonna calculate a counter, and by this counter we can calculate it easily, just checking the index from I to J, how many character replacement we can make it a palindrome, and we can enumerate all the possible cases, and actually we're gonna use the O(n) square. And secondly, we just need to use DFS because this counter is calculated. So while we are calculating the DFS for this counter, it is just O(1) time. So this means the final time complexity gonna be I times J, and let's just check I and J. So I gonna be the length of the string, it is 100. And J gonna be equal to K, it is also 100. So this means the time complexity gonna be n times K. N is the length of the string, and K is this K. It means O(n) square. It should be less than 10,000. So this means we can solve the problem easily by using this kind of idea. So now, let's just try to finish the counter. So this is gonna be a DP, and we need to have the length of the string. So n gonna be the length of the string. And now let's just prepare a counter. So this is gonna be a 2D array. So it's gonna be 0 times n for anything in range n. So this is gonna be the first step. So for the second step is that we're gonna need to calculate this counter. So for example, the counter from A to C, it's going to be 1. The counter from the B to C, it is 1 because we need to change the B to C or C to B. The counter from C to C, it is 0 because C is a palindrome by itself. We just need to calculate this. There are so many ways of calculating it, but I think the best way is we're going to use O(n) squared time. Yeah. If you use O(n) cubic time, it is still okay because n is just 100. But I prefer to use O(n) squared time. So let's just try to use this way. So we're going to use for I in range. So here is a trick. We're going to use 2 times n minus 1. Because in this line of code, actually we can check the left and right easily. Because it will include all the possible cases. So if this is a string S, so we're going to start from 0 index. But for this kind of line, we can prepare 0 index and 0 and 1 index together. So let's just prepare that. So we're going to prepare L and R, going to be the index starting point. And then we're going to expand it. I think this kind of idea is used a lot in Leetcode problems. So it is called spreading from the center. So we're going to spread the L and R pointer from the center. So L going to be I divided by 2, and the R going to be I divided by 2 plus I modulo 2. So this is really important for this kind of algorithm. So while we are preparing this, we just need to use the 2 line and prepare all the possible cases. So let's just use this example. So if I equal to 0, what's going to happen? I divided by 2 is 0, and I divided by 2 plus I modulo 2, it is also 0. So this means we're going to spread from this 0 index. So it is okay. If we spread, it go out of the range and we're going to stop. So this means the counter 0 to 0, it must be a 0 because it is 1 character. Yeah. Now, if I equals to 1, what happens? So I divided by 2, it is 0, and I divided 2 plus I modulo 2, it is 1. So this means for the L and R pointer, we're going to spread from 2 positions, 0 and 1. So in this way, it's going to include all the possible cases. Yeah, so 0, 1, it is okay. So we're going to check if the character, so for example, this is A and this is B. If they are not equal, so we're going to increase the count by 1. So if they are equal, so the count is still 0. So this is the idea. Yeah. Now let's just use this idea to solve the problem. So we're going to prepare a count. So the count is going to be starting from 0. So while L should be more than and equal to 0, and R should be less than n. So we're going to start to count. So we're going to check that. So if SL not equal to SR, yeah, so the left side is not equal to the right side. So what's going to happen is that the count is going to plus equal to 1. Yeah, and for each of the time, we need to put it inside the counter, inside the count DP array, or a 2D array. So inside the count, so I'm going to call it a 2D array, just a memorization of all the possible cases. So it's going to be L and R going to equal to the count. And after that, the L going to minus equal to 1, and R gonna plus equal to 1. So this is a spreading problem. So we're gonna spread from the center. So for each of the situations, maybe L and R is here, so we're gonna spread from the center, and we're gonna just check all the possible cases. Actually, this is a brute force, but we're gonna start from the center, because in this way, it's gonna be O(n) squared time. Now what happens for us is that we get a counter. So this counter gonna have all the possible cases, and now let's just check. Let me just make it maybe smaller. Yeah, let me just make it smaller. Maybe I don't know why. Maybe here. What happens? Yeah, so let me just code it. Oh, I don't know why. Yeah, everything is different. Let me maybe make it smaller like this. So let's just start it like this. Let me just run it to check what happens. Yeah, of course it is wrong, but at least we get a counter. So this counter has some meanings. So this means from 0 to 0, it means this character A, we don't need to have any replacement. It is a 0. And what about 0 and 1? It is 1, because from A to B, we need to have one replacement to let it become a palindrome. So this is okay. And now we're going to start the DFS. So yeah, let me just start the DFS. Yeah, so we're gonna define a DFS. So the DFS is gonna start from I to J. So we're gonna check the conditions. So from which condition we can set it to be a 0. So we're gonna set this in J. If J equal to I plus 1, so we're gonna return a 0. Yeah, let me just close it. It is annoying. Yeah, so this means I want to make a drawing, but let me try to check why. How can I let it go out and make a drawing? Maybe. Yeah, I don't know which place I clicked and it makes it really annoying. I cannot do anything about the screen. Yeah, but let me just explain it from here. So this J equals to I plus 1. So this basically means if this J, if J split, for example, if this J equals to 3 and I equal to 2, 2 plus 1 gonna equal to 3. So this means if I equal to 2, it means from index 0 to 2, if we have 3 characters and our split gonna be 3. So basically, if we have 3 characters and this k equal to 3, basically this means for each of the characters, it must be a palindrome. So what gonna be the final count of the replacement? Total replacement is gonna be 0. Yeah. But what if this J is more than I plus 1? Definitely it is not possible, so we're gonna prepare at infinity. Now we're gonna define the result as infinity, and we're gonna check all the possible cases. So for x in range, yeah, so let's check in range I. So in this way, we're gonna check all the possible cases, because x gonna be the at most x gonna be I minus 1. So in this way, it's gonna include all the possible cases. So it will go to the end of this I. So it's gonna start from I to minus 1. Yeah. So we're gonna start with this I, and this I gonna be starting from n minus 1, because finally we're gonna return this DFS. It's gonna be starting from n minus 1, and with this k. So this means from index 0 to n minus 1, and we're gonna split it into k parts, and what is gonna be the minimum of character chains. So this is gonna be the definition for the DFS. Now we're gonna calculate the minimum. So the result gonna be the minimum of the result with DFS. Here we're gonna starting from x minus 1. And for this J, it's gonna be minus 1 because we used it for one time. And we're gonna plus the counter. It's gonna be x to the add of the index for this I. And finally, we need to return the result. I'm not sure, but let's just run it to check. Yeah, it seems it works. But we cannot submit it yet because we didn't use the cast. So we needed to use the cast to decrease the time, because after using the cast, it's gonna be O in square time. Basically, it is n times k. Now let me just submit it to prove it works. Yeah, now I think it is let me run it from here. Yeah, I think it's because of the network. It's not okay. Yeah, normally we should get the result just in a few seconds. Now we don't have anything, but let me check. It seems it has already been submitted, but yeah, but we cannot see that. Let me just copy the code. Yeah, so from here we can see it is like 2 minutes ago it is submitted. Yeah, maybe let me just try again to check if it works or not. Yeah, it seems it works, and let me just submit it to check if it can pass. Yeah, I think the network is quite slow, and basically we cannot say anything about it. But this is the code, and the first step is we're gonna prepare a counter. So this counter is gonna be a 2D array. It is just to record all the possible positions from I to j. And from here, while we are using the DFS, because of this counter, here it's just O1 time. From here, it is just n times k for the time complexity. I think that's all for it. Thank you for watching. See you next time.